in this example, I'll show you. In this example, I'll show you using a whiteboard. Just you see that, whether you can see the screen, right? So here we are going to take, for example, you have two boys and one girl. Okay, two boys and you have one girl, right? So in how many ways can you place these people? If I have three chairs, okay, I have three chairs. In that chairs, I want to place these people. Clear? How will I place? Can anyone tell me how will we place those three people? In how many ways we can place them? Yes. Someone is responding. In how many ways can we place them? We can place these people in 3 factorial ways. That is in 6 ways, right? In 6 ways, we can place those people. Okay. Now coming to backtracking method. So in this backtracking method, you have different, how do we solve these problems is by using state space tree. State space tree ante meer last class lo gurtundachu. Manam trees draw chesam. Right? Those were there in my class. I told you all about trees, how to draw the trees. Right? Even if one solution is not possible, we are going to do the, we are going to backtrack and follow those other solutions. Right? So what we are going to do here, you're going to take n numbers and then group them into 2 different parts, right? You're going to group them into 2 different parts. If you can hear me, at least place a message that you can hear me. Yes, okay, message petandi that you can hear me at least. Yes, can you all hear me? At least one message so that I can understand that you all can hear me. Yeah, okay, fine. So I told you in backtracking, what do? You follow brute force approach. Brute force approach is nothing but you're going to find different solutions. So there is no single solution. We have done dynamic programming in the class. Dynamic programming is related to optimization solution. That is, we get exactly one solution. Whereas in brute force method, you get multiple solutions, right? So coming to these applications of backtracking, first one, you have 8 queens problem, right? 8 queens problem is nothing but, just see here. So coming to 8 queens, ante queens problem ante manaku oka chessboard untundi, right? You are going to place the queen on the chessboard in such a way. This is one application of backtracking, right? So this chessboard, I hope you all know what do you mean by chessboard. We have already, yeah, we already used this chessboard. In that you have a queen, king and queen, right? Now you should place this queen, only a queen in this chessboard such that no 2 queens should be on the same row. This is row, right? This is column and this is diagonal. So the condition is that no 2 queens should be placed on the same row, same column or same diagonal, right? Like that, we are going to backtrack. Now, for example, let us go to 4 queens problem. Now, in this, I am going to place my queen in the first row. So, how are we going to place? See, simultaneously, I'll be opening whiteboard also so that you can understand what we are trying to do. Yeah, I will be opening whiteboard. Yeah. Now here, this is my chessboard, right? So I'm taking 4 by 4 problems because it will be convenient for me to draw. Okay. So in this backtracking method, what you do is, this is a 4 queens problem, right? I'm going to place this queen in this chessboard so that they do not go on to the same row, same column and same diagonal. This is the rule, right? Yes. So how are we going to place? Now this is the root. I'm going to place Q1, queen 1. Okay. As this is 4 queens problem, I'm placing Q1 here. See, someone is disturbing. I don't like anyone disturbing. Wherever draw cheste nenu mimmalni teesestanu class loki. Please. See, still someone is drawing. Meer ila draw cheste nenu cheppanu. Now, how are we going to place these queens here? Now, when I am placing Q1 here, in this problem, in this possibility, Next, if I place Q2 here, this is queen 1, right? This is queen 1 and this is queen 2. Can I place Q2 here? No, I cannot place Q2 here. So what should I do? I should backtrack. Clear? I should backtrack so that then in the next possibility, I'm going to place Q2 here. I'll show you using the diagram. It is the same diagonal. So you cannot follow this particular procedure. So what you're going to do, you're going to place Q3 in this particular box. Clear? So what is happening here? So what are we doing here? I am taking a 4x4 chessboard. Here, I am taking a 4x4 chessboard, right? So in this 4, yes, who is that? Huh? Bindu. Emma. If you're not interested, you be quiet now. Why are you drawing? Please, you note down this in your book. So here you're having 4 queens, right? So how will you draw this diagram is, chudandi, Deepthi Reddy anta, chudandi. If you disturb like this, how can I draw, explain yalama? Cheppandi. Now this is the root, okay? For every problem, there will be a root. So here, what you're going to do, you're going to place the first queen, that is x1. x1 is equal to 1 when I am placing in the first column, right? When I am placing this queen here, right? So what is the next possibility? I cannot place Q2 here. This is not allowed. Clear? Next, what will I do? I cannot place Q2 in the second column. Here, I cannot place Q2 in the second row. Then what will I do? I am going for the next possibility, Q3. So, x2 is equal to, it is placed in the third column. Clear? Next, what you do? You're going for this particular procedure. Next, you're going to place Q2 queen here. Next, I'm going for the third procedure. Next, can I place Q3 here? I cannot place Q3 here because it is not following the rule of queen's problem. So n queen's problem states that no two queens should be in the same row or in the same column. Next, what am I doing? Just I'm putting it here. See, I'm going to put Q3 in the first column. So this is not allowed. Clear? Next, when I'm putting Q3 here, this is allowed, but the conditional of diagonality is applicable here. So even this one is going to fail. So what am I doing? X3, I'm going to put in 2. So it is not allowed because it is not following diagonal. It is following diagonality rule. Next, I cannot put queen 3 here. Whereas I cannot put queen 3 here because it is following diagonal. So ఇప్పుడు ఇక్కడ ఏం చేస్తామంటే ఇక్కడ నుంచి backtrack. We are going to backtrack here. Clear? Backtracking అంటే పాత దగ్గరికి వెళ్ళి మళ్ళీ ఇక్కడ నుంచి సాల్వ్ చేసుకుంటూ వస్తాం. So queen 1 will be in its same place. I am going to backtrack queen 2. So what is the place of queen 2? Just see here. Now I am trying to put queen 2 here. Okay, let us see the concept now. Queen 1 is in the same place. Now queen 2, in the first possibility, it is not allowed. In second possibility, it is not allowed. In third possibility, it was allowed, but it is not accepting Q3 here. So next, what am I doing? I'm putting queen 2 in the fourth row. That is, sorry, fourth column. Okay, queen 2. This is queen 2. This is queen 1. Clear? So this is put in fourth column. Next, coming to queen 3. So what will I do to queen 3? Can I put queen 3 here? No, it is not allowed. Can I put queen 3 here? Yes, it is not following diagonality rule, nor the same row, nor the same column. So what is happening? Queen 3 is placed in the second, that is third row, second column. This is queen 3. Clear? Next, what am I doing here? I am putting queen 3 here. Clear? Next, coming to queen 4. Can I put queen 4 here? No, it is not allowed. So it won't allow queen 4 in the first row. Next, queen 4 in the second row. Sorry, in the second column. No, it is not allowed. queen 4 in the third column. This column I'm talking about. Fourth row, third column. So it is not allowed as it is following a diagonality rule. Next, what will I do? I'm putting queen 4 here. So does it satisfy the rule? No, it does not satisfy the rule, right? Because this is in the same column. ఇప్పుడు ఏం చేయాలి మనం? మళ్ళీ ఇక్కడికి వచ్చి బ్యాక్ ట్రాక్ చేయాలి. ఇక్కడికి వచ్చి బ్యాక్ ట్రాక్ చేసిన ఇప్పుడు Q3, if I put it here, it will become diagonality rule. So what will I do? I'll backtrack to Q2. So again, if I backtrack to queen 2, there is no possibility. So what do I have to do? I have to backtrack to Q1. So queen 1 ni position marchi manam try cheyali. That is called as backtracking. So if you are given a question, explain 4 queens problem. So in 4 queens problem, what do? You have to write like this. See, I'm sharing my screen. Just I'll show you how to write the answer, right? I'm sharing my screen, 1 minute. Yeah. See, in this one, I'm showing you how to write this one, right? So here, you're going to write 4 queens problem follows the process of backtracking where there are 4 queens and how many answers will you get? You're going to get 16C4. That is different possibilities you're going to place the queen. So like that, you have 8 queens problem. Next, you have 16 queens problem and you have n queens problem. So can n queens be placed on an n by n chessboard? So it's an n by n chessboard, right? So that no queen may attack another queen. Attack ante enti? Same row రావద్దు, same diagonal రావద్దు, same column రావద్దు. దాన్ని attack antar. Constraints, those are the different constraints that you're going to take. Like this, you're going to solve the problems. So you're going to draw the tree like this. Itla draw చేస్తారన్నమాట. Right? Now I showed you the picture, right? How to draw. So like that, you're going to draw. So let us see, complete that particular answer. How to do it. I'm showing it. 1 minute. Yeah. 1 second. Yeah. Just see, yeah. So I'm taking this chessboard. So in the answer, you have to write it like this. You are going to take the chessboard. This is a 4 by 4 queens problem. Clear? This is a 4 rows, 4 columns problem. Okay na? So ఇప్పుడు మనం ఏమనుకున్నాము? Queen ఎప్పుడు మనం ఇలా రూట్ పెట్టుకోవాలి. రూట్ పెట్టుకొని నెక్స్ట్ క్వీన్ 1 పాసిబిలిటీ ఏంటి? ప్లీజ్ అమ్మా మీరు ఇట్లా డిస్టర్బ్ చేస్తే బాగోదు, చెప్తున్నా మీకు. ప్లీజ్, అస్సలు బాగుండదు. మీరు ఇలా చేస్తే నేను ఏం చెప్పాలమ్మా మీ క్లాస్? చెప్పండి. సో క్వీన్ 1 ఐఎమ్ గోయింగ్ టు ప్లేస్ ఇట్ హియర్ బికాస్ మనం ఒక పాసిబిలిటీ చూసుకున్నాము. సో queen 1, I'm putting it here. Okay, queen 1, can you hear me? Queen 1, I'm putting it here. Next, coming to queen 2. See, you're disturbing me like this. If you disturb like this, it won't be good. Clear? Next, queen 2 ఏం చేస్తాము? Queen 2, 4 possibilities ఉంటాయి, right? I'm going to put queen 2 here. If I put it here, it is not allowed. If I put it in the second row, it is not allowed. If I put it in the third row, it is not allowed. Clear? Next, I'm going to put the queen in 4th row. This is second queen. Clear? This is queen 2. Next, queen 3 ఎక్కడ పెడతాం చెప్పండి? బాలాజీ unmute చేయమా? బాలాజీ పడవాలా? Please unmute. Balaji, please unmute. Unmute. Next, you're going for queen 3. Can I place queen 3 here? Because it is not following the same row nor the same column. చూడండి, ఇక్కడ same row లేదు, same column లేదు, same diagonal లేదు. So I'm going to put here queen 3 is going to come in the first column, right? Like this. Next, coming to queen 4. ఇప్పుడు ఎక్కడ పెట్టాలి queen 4? చూడండి, I cannot put it here, nor here, nor here. So what is happening here? I am putting queen 4 here, right? So ఇప్పుడు దీన్ని ఏమంటారు? దీన్ని అంటే killing the state. I'm going to kill the state saying that it is not working based on the given condition. So this is called as four queens problem. Hope it is clear. Please message, reply. Can you hear me? At least message. Are you clear with the four queens problem? Four queens problem, okay na? Is it clear? Shall we go to the next concept of backtracking? Shall we go to the next concept of backtracking? Ma, at least one of you message, Amma. At least a message petandi, so that we can go to the concept, the next concept. Yeah. So ఇప్పుడు ఇక్కడ మనకు ఒక్కటే సొల్యూషన్ ఉండదు, రైట్? యూ విల్ గెట్ మల్టిపుల్ సొల్యూషన్స్. సో ఇప్పుడు మనం ఏం చేసాం ఇంతకు ముందు? I have put it in. See, I have put Q1 here, Q2 here, Queen 3 here, and this is one possibility. ఇప్పుడు నెక్స్ట్ పాసిబిలిటీ ఏంటి? 1 ఇక్కడ పెట్టుకోవచ్చు, 2 ఇక్కడ పెట్టుకోవచ్చు, 3 you cannot keep here. So I'm putting 1 here, 2 here, 2 here, 3 here, and 4 will be here. Like that, you will get multiple solutions. That is called as backtracking. Fine, that is called as backtracking. Now let us remember one concept. Backtracking follows a depth first search approach. Okay, tree traversals lo two types of traversals untai. నేను లాస్ట్ టైం వచ్చినప్పుడు చెప్పాను, బ్రెత్ ఫస్ట్ సర్చ్, డెప్త్ ఫస్ట్ సర్చ్. సో డెప్త్ ఫస్ట్ సర్చ్ అంటే ఏం చేస్తుంది అంటే డెప్త్కి వెళ్ళి లీఫ్ వరకు వెళ్ళి చెక్ చేసుకుంటూ బ్యాక్ ట్రాక్ చేసుకుంటూ వస్తుంది, రైట్? That is called as depth first search. So backtracking follows depth first search. Fine. Next, let us go to the next concept. Now just here, these are the answers you will get. The possibilities you will get is 2. You're going to get 2. మీరు చేయొచ్చు, ట్రై చేయొచ్చు. 4 queens ప్రాబ్లంలో ఆన్సర్ వచ్చేసి 2, 4, 1, 3. ఇది ఒక పాసిబిలిటీ. నెక్స్ట్ వచ్చేసి 3, 1, 4, 2. ఇది ఒక పాసిబిలిటీ. 4 queens ప్రాబ్లం. ఇట్ ఈస్ అ 4x4 queens ప్రాబ్లం. ఓకేనా? లైక్ దిస్ ఈస్ ద మిర్రర్. ఒరిజినల్ ఆన్సర్ కి మిర్రర్ ఇమేజ్ వచ్చేసి దాని ఇంకొక ఆన్సర్. అట్లా మనకు మల్టిపుల్ సొల్యూషన్స్ రావచ్చు, కానీ 4x4 వచ్చేసి 2 సొల్యూషన్స్ వస్తాయి, రైట్? యూ క్యాన్ టేక్ దిస్ వన్. నెక్స్ట్ లెట్ us go to the next concept. Let us go to the next concept. 1 minute, I'm sharing my screen. Yeah, let us go to the next concept. Coming to, you are having sum of subsets problem. ఇది ఒకటి sum of subsets problem. Fine. Yeah, now coming to sum of subsets problem ఏం చేస్తుందంటే, yeah, just here in sum of subsets problem you are going to have n అంటే మన టోటల్ నంబర్ ఆఫ్ ఆబ్జెక్ట్స్. అమ్మ చూడండి, మీరు ఇలా చేస్తే బాగోదు, అస్సలు బాగోదు. క్లియర్? ఐ విల్ ఇన్ఫార్మ్ యువర్ సార్. యు ఆర్ హ్యావింగ్ 6 objects, right? And their weights, right? We have talked about this in dynamic programming, right? So you are holding these objects, 6 objects, and their weights are, right? You are having the weights as 5, 10, 12. You can note it down. 13, 15, and 16. Srivardhan, can't you be quiet? So we have to take the subset. Subsets అంటే ఏంటి? Sum of sets is called as a subset. ఒక set లో different subsets ఉంటాయి. దాన్ని sum of subsets problems అంటారు. Right? That is called as sum of subsets problem. So here what you are doing, you have to do the selection of these weights in various ways. So ఇది ఏంటంటే either you will put this object in the bag completely or you do not put it completely. Clear? So how will you put it? Just see. You're going to take a root node, right? In this, I'm going to put the first object. If I put the first object, okay, if I put this object, right, it will become 1. If I do not put x1, right, if I do not put x1, it becomes 0. అంటే దీని వెయిట్ మనం యూజ్ చేయకపోతే, కన్సిడర్ చేయకపోతే 0 అవుతుంది, కన్సిడర్ చేస్తే 1 అవుతుంది. క్లియర్? So how do we do this? You just see this. This is the method. I'll tell you the problem. Right? Next, again, I'm going to put x2 in the bag. If I put x2 in the bag, the weight will become 1. Okay, na? Similarly, I'm going to put x3 in the bag. x3 in the bag. And how many weights are there? There are 6 weights totally. Right? There are 6 weights totally. So depth first changes to the all these, it will go till the leaf node. I'm going to put x4 is equal to 1. Then bag lo pedutunanu. Next, like this, x5 and x6 I'm going to put in the bag. Right? Next, what will I do? If I do not put, what will happen? You're going to get x2 is equal to, you're going to get x2 is equal to 0. Like this, you are going to get x3 is equal to 0. So ఇప్పుడు మనం ఎలా చేస్తాం దీన్ని? ఇలా చేయాలి. ఇప్పుడు నాకు ఇది పాసిబిలిటీ వద్దు నాకు అంటే బ్యాక్ ట్రాక్ చేస్తాం. ఇక్కడికి వచ్చి చేంజ్ అవుతుంది. సో హియర్ x1 will be 0. Then when x1 is 0, you may put x2 into the bag or you may not put x2 into the bag. Clear? So let us go to one problem. All of you please take down this problem. All of you please take down this problem. Write down. There are 6 objects in the bag. Sorry. There are 6 objects. There are 6 objects and their weights. The weights of the objects are, and the weights of the objects are W of 1 is to 6. You have to write down like this. W of 1 is to 6. Right? So these weights are, take down the weight. The weight object is 5. The weight of the second object is 10. The weight of the third object is 12. The weight of the fourth object is 13. The weight of the fourth object is 15. The weight of the, sixth object is 18. Okay. Again, I'm repeating. The weight of the first object is 5, 10, 12, 13, 15, and the size of the bag is 30. అంటే ఈ బ్యాగ్ లో మనం వెయిట్స్ వచ్చేసి 30 వచ్చేలాగా పెట్టుకోవాలి. అంతకన్నా తక్కువ రావద్దు, అంతకన్నా ఎక్కువ రావద్దు. రైట్? సో వాట్ యు ఆర్ డూయింగ్ హియర్? అమ్మా ప్లీజ్ మీరు ఇలా డిస్టర్బ్ చేయకండి అమ్మా. ప్లీజ్ డోంట్ డ్రా ఎనీథింగ్. Do not draw anything. Yeah. So what I am doing, I'll just take like this. Yeah, I'm taking a circle, right? So here I'm going to put like this. Here I'm taking, okay? Yeah, I'm taking a circle. In this, I'm going to put the weight of the first bag like this. So ఇక్కడ చూడండి ఎలా పెట్టుకోవాలి. ఇది రూట్ నోడ్, రైట్? ఇది రూట్ నోడ్. Yeah, I'm putting it like this now again. So this is the root node. From this, if I put the weight of the first bag, x1 is equal to 1. సో ఇప్పుడు ఏమవుతుంది, ఇక్కడ పెడుతున్నా చూడండి, ఈ డయాగ్రామ్ కూడా ఇక్కడ పెడుతున్నాను. సో ఫస్ట్ అట్ ద రూట్ నోడ్ దేర్ ఈస్ నో వెయిట్ అండ్ ద టోటల్ వెయిట్, ఇక్కడ వెయిట్ ఇంతకుముందు చెప్పాను కదా, 5 + 10 + 12 + 13 + 15 + 18. సో ద టోటల్ వెయిట్ ఆఫ్ ద బ్యాగ్ ఈస్ 73. ఆబ్జెక్ట్స్ వెయిట్ వచ్చేసి 73 అనమాట. నేను ఫస్ట్ ఇప్పుడు x1 ఆబ్జెక్ట్ని ఇలా పెడుతున్నాను. ఈ బ్యాగ్లో పెడితే ఏమవుతుంది చూడండి. When I'm putting x1, so what is happening here? x1's weight is 5, right? x1's weight is 5. So the weight of the first object, comma, then total objects weight నుంచి 5 తీసేయాలి. 68. ఎందుకంటే 73 - 5, you're going to get 68. So I'm placing the first object in the bag. Next, I'm going to take the second object. Okay na? Still మన టోటల్ బ్యాగ్ సైజ్ ఎంత 30. అంటే ఇంకెంత ఉంది మనకి చూడండి అమ్మా, మీరు ఎలా చేస్తున్నారో. నేను ఏం చేయాలి ఇప్పుడు చెప్పండి. See how you all are doing. If you are not interested, why do you all tell us to take the class? Yes. Yeah. See again. సార్ సోమేశ్వర్ సార్ చూడండి ఒకసారి ఎట్లా చేస్తున్నారో పిల్లలు. Just see. Yes. So what you're doing here, I am taking the objects. Sir చూడండి సార్ ఎలా చేయమంటారు. So here I'm taking the total weight. There are no objects and there are 73 total weight of this bag. So when I'm placing the first object, so the weight of the first object is 5. So 73 - 5, the total weight will be 68. So in this I'm putting the first bag, first object. Next, again I'm putting the second object, x2 equal to 1. Okay. Just here. So I already told you what is this. So there are no objects and its total cost or total weight is 73. Now when I'm putting the first object inside this, its first object's weight is 5. So 5 comma this object's total weight minus 68. Next thing is I'm going to put the second object here. When I'm putting second object, its weight is 10. So already 5 undi ganaka 68 అయిపోయింది ganaka I'm going to write here 5 + 10 is 15. 5 + 10 is 15, comma 58. Right? I'm putting the second weight of the bag. Next, ఇంకా మన దగ్గర ఎంత ఉంది? ఇంకా మన దగ్గర ఎంత ఉంది weight? You can put up to 30. Right? Next, I'm going to put the third object inside the bag. So when I put the third object, its weight is how much? The third object's weight is 12. So 15 plus 12 will be 27. 27. From 58, remove 27. How much will it become? Sorry, from 73, remove how much? 12. So 73, if you remove 12, how much will it become? 46. Next, ఇప్పుడు ఎంత అవుతుంది చూడండి, weight 27. Right? Next, I'm going to put this fourth weight into the bag. When I put the fourth weight into the bag, its weight is 13. So 27 plus 13 ఎంత అవుతుంది? 40 అవుతుంది. కానీ మన బ్యాగ్ సైజ్ ఎంత ఉంది? 30. సో ఐ హ్యావ్ టు కిల్ దిస్ ప్రాసెస్. కిల్లింగ్ అంటే ఏం చేస్తున్నామంటే దాన్ని ఇగ్నోర్ చేయాలి. ఇగ్నోర్ చేసి బ్యాక్ ట్రాక్ అవ్వాలి. సో ఇప్పుడు మనం 6 ఆబ్జెక్ట్స్ పెట్టాలి. అందులో మనం ఆల్రెడీ 3 ఆబ్జెక్ట్స్ పెట్టాం, రైట్? Now when I'm going to the fourth object, when I'm putting the fourth object, the weight is becoming more. So I don't want to put the weight of this object here. So what am I doing? So what will happen? It will become, the same weight will come down here. So 26, 7. నేను ఇప్పుడు పెట్టక ముందు ఎంత ఉండే? 27, 46. This is the weight still which is there. So I am not putting the x4th object in the bag. Clear? X4 object is 0. Next, what am I doing? Okay. So next I am going to put x5. x5 weight pedte ఏమవుతుంది చూడండి. x5 weight ఎంత ఉంది? x5 weight is 15. So 15 అంటే 27 plus 15 ఎంత చెప్పండి? 27 plus 15. It is then 42, sorry, 43. Right? Next, what is happening? 46 minus 15. How much will it become? It will become 31. So ikkada weight enta ayipindi already. So it is 43. So you are ignoring this also. So manam fifth object kuda pettaddu. Pettaddu ante em avutundi? It will become 27. The weight will remain like this only. 27, 46. Clear? Next, what am I doing? I am going to put the sixth object. ఇప్పుడు నేను పెడితే ఏమవుతుంది చూడండి. Sixth object పెడితే what is its weight? Its weight is 18. So 27 plus 18 ఎంత? It is going to become 45, right? So when I am putting this weight, it is going to become 45 and the total size will become 1. So what is happening? It is more than the size of the bag. ఇప్పుడు ఇది పెట్టకపోతే ఏమవుతుంది చూడండి. It is going to become 27, 46. So ఇప్పుడు మన బ్యాగ్ weight ఎంత? Totally 30, right? So as of now, this is the optimal solution. ఒక solution. Let us go to the back. అంటే ఇప్పుడు ఏం చేసాం మనము? Here you have not taken the weight of the bag of x6, right? I'm going to backtrack. Next, మన possibilities ఎన్ని find out చేసాం? దీని possibility అయిపోయింది, దీని possibility అయిపోయింది. Now let us go here, right? I have taken the size of x here. Which one? Third weight. So if I do not take, that is the other possibility. So మీరు exam ఎలా రాస్తారు? You are given a question. You should not write any algorithm about that. You should just explain this problem. Like how am I showing you? Kill it. So if you are going to kill it, you're going to write it, kill it. Because it is not following the rule. Because it is more than the size of the bag. Clear? So we are going to kill it. And next again, I'm going to not put the bag of x2 here. So what will happen? ఇప్పుడు నేను పెట్టకపోతే ఏమవుతుంది చూడండి. The same weight will come down. 15 is a size because I did not put x2 inside it. And the total size is 58. ఇది total ఏంటిది? అన్ని bags weight కలిపి 58. Right? Next, what am I doing here? Here x1, x2. ఇప్పుడు x2 ని పెట్టకుండా చూస్తున్నాం, రైట్? x2 ని పెట్టకుండా చూస్తే మళ్ళీ x3 ని పెడతాం ఇక్కడ. పెట్టినప్పుడు ఏం చేస్తుంది వెయిట్? సో వాట్ విల్ హ్యాపెన్? వాట్ ఇస్ ద వెయిట్ ఆఫ్ x3? See, I am taking here so that you can clearly understand what it is. I am taking here the weight of x3 is 1. ఇప్పుడు వెయిట్ x3 పెడితే ఏమవుతుంది చూడండి. x3 weight వచ్చేసి ఎంత? 12. So 15 plus 12 ఎంత? 27, right? సో 58 లకి 27 తీస్తే ఎంత అవుతుంది? 31. అంతేనా? రైట్. నెక్స్ట్ ఇప్పుడు నేను ఏంటిది? x3 I have placed in the bag. Okay, x3 is equal to 1. Next, let us go to x4 పెడితే ఏమవుతుంది ప్రాసెస్? x4 పెడితే ఏమవుతుంది చూడండి ప్రాసెస్. So when I'm putting x4, what is happening here? Just here. Please do not disturb, Amma. If you're not interested, you can just sit idle. Right? So when I'm putting x4 in the bag, just here, x3 is already placed in the bag, x4 is equal to 1. Right? When I'm placing x4 is equal to 1. Can anyone tell me what we have to do here? Cheppandi evarona okaru unmute cheyandi. When I'm putting x4, the size of x4 is 13, right? Object 4 is 13. So if I add 13 here, what is happening? The weight will become 40. So this is more than the size of the bag. So you cannot place x4 here. Now let us go with x4 equal to 0. Ante manam x4 pettatledu bag lo. x4 is equal to 0. That time what will happen? It will become 27. The same weights will come down if you are not putting the objects in the bag. Clear? Remember that you are not putting the objects. Next, I'm going to place x5 in the bag. x5 into the bag. If I place x5 into the bag, what will happen? Yes, the size of x5 is 15. So if I put 15, what will happen here? 27 minus 15, the answer is 12. Sorry, 27 plus 15 ఎంత అవుతుంది? 42. So it is more than the size of the bag. So even this is not allowed. So you have to show all these possible. దీన్ని స్టేట్ స్పేస్ ట్రీ అంటారు. ఈ ట్రీని స్టేట్ స్పేస్ ట్రీ, రైట్? కిల్ ఇట్ అని చెప్పేసి మీరు ఒక సొల్యూషన్ ఏదైతే వస్తుందో దాన్ని రౌండ్ చేసుకుంటూ వెళ్ళాలి, రైట్? సో హియర్ దిస్ ఇస్ ద సొల్యూషన్. యూ హ్యావ్ టు ఫైండ్ అవుట్ లైక్ దిస్. So up to now 27 was the best solution, right? If you do this problem, you will get maximum solutions but not optimal solution. Optimal solution ante remember pettukondi. Just remember that is optimal ante correct solution with maximum profit. Maximum solutions or minimum weight is nothing but you are going to use backtracking. Okay, backtracking use chestam manam, right? So this is one type of sum of subsets problem. So in this you do not have any algorithm, you will be having only problems. Remember that. So sum of subsets problem is nothing but it is collection of set of sums, right? So yes, here I'm going to share my screen, just a minute. Yeah, now just here, just now what I told you, this is the solution. Now just here, subset tree for n is equal to 4. So it is a fixed size tuple. మనం ఫస్ట్ x1 ఒక ఆబ్జెక్ట్ ఇలా పెట్టుకుంటాము. పెట్టుకుంటే పాసిబిలిటీస్ ఏంటి, పెట్టుకోకపోతే పాసిబిలిటీస్ ఏంటి? సో మనకి ఇచ్చిన సైజ్ కన్నా తక్కువ సైజ్ స్పేస్ ఉండాలి. cannot take more than that size, the weight of the bag. This is called as state space tree. Remember that. This is called as state space tree, right? Where you get different solutions. Clear? So coming to this one. So backtracking searches a solution space tree in depth first manner. Okay, this is done recursively. What do you mean by recursive? Recursive means you are using the same solution repeatedly, right? So here you may get, many of them will get different solutions. Clear? So like this, you have to put the diagram. Clear? You can just see here, ila chudandi, meer ila add cheskunటూ వెళ్ళాలి. So if x1 is allowed, what about here? ఇది root node అనేది దేనికి తీసుకోరు. From here x1 will start. This is x1 is equal to 1, x2 is equal to 1, x3 is equal to 1, x4 is equal to 0. So it allows only 111 possibilities for a particular problem. Clear? Like this, you are going to solve the problems. This is called as sum of subsets problem. Yeah. Now let us go to the next concept of backtracking. What is the next concept you have? Go to the next concept. The next concept is about graph coloring. Okay, graph coloring. ఇక్కడ చూడండి n queens problem అని చెప్పాను కదా ఇంతకు ముందు. So here you're going to put like this. So you're just going to write about the queens like this. Okay, tree structure for the case n. ఇన్ని possibilities వస్తాయి case కి. Right, x1 is equal to 1. ఇప్పుడు x1 is equal to 1 అయిపోయింది కనుక మనకు పాసిబిలిటీ 2, 3, 4. రైట్, 2 అయిపోయింది కనుక 3, 4. 4 అయిపోయింది కనుక 5. సారీ 5 అంటే నెక్స్ట్ రో నంబర్ తీసుకుంటున్నాం మనము. 4 క్వీన్సే కనుక 4 పాసిబిలిటీసే వస్తాయి. ఇక్కడ చూడండి 4, 6 అంటే 3, 4. దిస్ మీన్స్ దాట్ 3 and 4. సో హియర్ x4 is equal to 4 అంటే ఫస్ట్ క్వీన్, సెకండ్ క్వీన్, థర్డ్ క్వీన్ అండ్ ఫోర్త్ క్వీన్ you're putting in this particular possibilities. Like this you're going to give. Okay, see here, this is the possibility. Right, like this you have n queens problem. Okay, this is sum of subsets. Just now I told you, in the sum of subsets, how do you put the particular problem? Right, you have a fixed size tuple and a variable size tuple. Fixed size tuple is already done, and this is the various, that is fixed size tuples. Right, so here backtracking solution uses fixed size tuple. Fixed size ante size అనేది ఎప్పుడు చేంజ్ అవ్వదు. మనకి n is equal to some సొల్యూషన్ ఇస్తాడు, వాల్యూ ఇస్తాడు. ఆ వాల్యూ ప్రకారమే మనం ప్రాబ్లమ్ సాల్వ్ చేయాలి. సో దిస్ ఇస్ నథింగ్ బట్ weight and xi, right? That is the previous, the weight and the previous one. This is the bounding function. Okay, like this you keep calculating it. Ivanni manaku avasaram ledu, just see here. This is sum of subsets problem. Just now I told you n is equal to 6, m is equal to 30. So n is equal to 6 is nothing but 6 objects. M is equal to the total weight. W of 1 is to 600. These are the weights of them independently. So when you are putting them like this, these are the possibilities. Okay, na? These are the possibilities you get. So this next, coming to graph coloring problem. Graph coloring problem ante manaku oka graph istaru. Right, I told you in the class, graph is like this. Okay, in this graph you have to assign the colors to the vertices. The vertices ki manam colors ivvali such that no two vertex, okay, no two vertices should be of the same color. Okay na? So number of colors used here are 2. What condition is there? Explain graph coloring problem where number of colors used are 2. So you're going to take 4 or 6 or whatever you're going to take. You should see that no two vertices are of the same color. Clear? Let us do that one. I will show you. See, this is the solution you are going to find. So we will do it and I'll show you. Okay, itla chupise మీకు clear గా అర్థం కాదు. I will do it. We will see the coloring. Fine. So this is the algorithm. I'll explain this algorithm once we complete the particular problem. Fine. 1 minute. Just a minute. Yeah. So here what you're doing, I am going to take here, imagine. Okay, till sir enables me, I will show you what is this. So this function, it is nothing but assigning the graph to its adjacency matrix. Okay, na? I told you about adjacency matrix. Hope you remember what I told. You are going to take a matrix like this. Yeah. Here I'm going to take one. I'll just show you simple one. So here what you're going to do, you're going to take an edit option. Okay, fine. So you're going to take Let's see it and do it. So here you're going to do algorithm M coloring of K. That is how many this one you're going to take. Adani coloring తీసుకుంటాం. Right? So here, fine. So here what you're going to do, you're going to take K is the index of the next vertex to color. Ante first vertex, second vertex, third vertex. Like that you have to color. You are going to repeat it. You're going to assign from first vertex, you're going to the second vertex. If x of k is equal to 0, then return అంటే ఒక కొత్త కలర్ లేకపోతే మనం రిటర్న్ అవుతాం. సేమ్ కలర్ అవుతేనేమో మనం డ్రా చేయొద్దు. గ్రాఫ్ కలరింగ్ ఏంటి అంటే you're going to assign different colors to the adjacent vertices. You're going to assign different colors to the adjacent vertices. Remember that concept. So if k equal to n, then you're going to color the diagram. So let us see given the option. Okay, let us discuss this till then. Right? So how are you going to draw the colors is like this? Yeah. So here, this is the first vertex. అంటే గ్రాఫ్ అంటే ఇలా ఉంటుంది. ఇలా ఉంటుంది. సో ఈ గ్రాఫ్ కి ఇప్పుడు ఒకవేళ నేను రెడ్ ఇస్తే, ఇక్కడ నేను ఒకవేళ రెడ్ కలర్ అసైన్ చేస్తే దీనికి, ఈ పక్కదానికి దీనికి రెడ్ కలర్ అసైన్ చేయడానికి ఆప్షన్ ఉండదు. రైట్? సో హౌ ఆర్ వి టేకింగ్ ఇట్ హియర్? ఐఎమ్ గోయింగ్ టు అసైన్ ద ఫస్ట్ వన్, దట్ ఈస్ రెడ్ కలర్ హియర్. Right, when I assign red color here, the second or the fourth vertex here, you just see here, in this case, I am assigning 3 different colors for the first node. When I am assigning, there are 3 colors. You can just see it's a 4-node graph and all possible 3 colorings. So for the first vertex, I am giving 3 different colors. So when I am assigning the first color, first color ante red, second color ante green, third color ante blue. So you put the red assign yesterday, then green or blue you can assign, right? So when I'm assigning here green, the third option will be either red or blue. Next, when I'm assigning 1 and 3 here, at the 4th level. So within levels antaru, right? So you're going to put them in the different levels. So once you complete this pattern, only then you get back and complete the next pattern. One అయిపోయిన తర్వాత అంటే ఫస్ట్ పాసిబిలిటీ అయిపోయిన తర్వాత మనం బ్యాక్ ట్రాక్ చేసుకుంటూ వెళ్ళి నెక్స్ట్ పాసిబిలిటీకి వెళ్తాం. క్లియర్? లైక్ దట్ we go. So hope you all are there in the class. Only 12 students. Fine. Right? So this is one possibility. So ఇప్పుడు ఇక్కడ ఏమవుతుంది, when I'm assigning 1, I can either assign 2 or 3. Now I don't want to assign 1 here. అందుకంటే 2 అవ్వకపోతే ఇది 1 అవ్వచ్చు, 3 అవ్వచ్చు. ఎందుకంటే 2 కి నెక్స్ట్ అడ్జసెంట్ వర్టిసెస్ వచ్చేసి 1 and 3. So if I'm putting 1, this is the possibility. If I'm putting 3 color, third color, this is the possibility. Clear? ఎందుకంటే ఇది 1, ఇది 2, ఇది 3, right? 2. So already 1 is done. So I'm going to take 2. Clear? Next, like this. If I don't want these colors, I will backtrack till here. When I backtrack, it becomes 3. 1, either 2 or 1, 3. 1, 3 అయినప్పుడు నెక్స్ట్ వచ్చేసి ఆటోమేటికల్ గా 2 అవుతుంది. 2 అయినప్పుడు ఇక్కడ either 1 or 3 you may get. You may get here 1 or 3. So if you get 1 here, you will get 2 here. Fine. Next, like this we color. You please take it down. This is the foregraph, right? This is the foregraph. You're going to color it like this. X1, this is the first vertex, second vertex, third vertex, and fourth vertex. So this is about graph coloring problem. Now, so here, what are the different possibilities you will get? Let me take a new slide and I will show you there. Yeah. Now just see here. ఇప్పుడు ఇది ఒక circle, right? I'm going to put a circle here. Right? I'm putting a circle here. Here. Right? ఇది ఒక circle. ఇది second circle. Next. ఇది ఇంకొక possibility. And this is the third possibility, right? So ఇలా ఏం చేస్తాము, second color తీసుకుంటాం. Fine. You're taking the second vertex. This is the second vertex. For this, if I give red, okay? So ఇక్కడ చూడండి అమ్మా, 4, what is this? N is equal to 4, colors equal to 3, right? So when you're taking the output, the solutions, what you get will be red, green, red, green. This is one option. Red, green, red, blue. అంటే ప్రతి ఒక్కటి దాని పక్కన ఉండదు, same color. Or you can get green, red, green, red. This is another possibility. Next, you will get red, blue, red, blue. This is one possibility. You will get red, blue, red, green. This is the other possibility, right? These are the different solutions for this graph with 4 vertices and 3 colors. Right, this is the graph with 4 vertices and 3 colors. Now, for example, you will take down one question. In that, I'm taking a graph. N is equal to 6, and the colors used are 3 of them, 4 this one. So what are the different possibilities, right? N is equal to 6 means nothing but vertices. You are going to use 6 vertices. 6 vertices అంటే వీటి మీకు నేను క్లాస్లో చెప్పాను, లేదంటే మీకు సార్ వాళ్ళు చెప్పుండొచ్చు. In data structures, these are the vertices. So this is the first vertex, and again you're going to draw from this, you're going to get a second vertex, right? We have drawn in graphs. Next, you get a graph. This is the third vertex, right? Again, you get another one. This is the fourth vertex. Clear? ఇలా మనం 4 vertices అంటే ఇప్పుడు నేను 6 vertices అన్నాను. సో ఈ vertex సేమ్ కలర్ ఉండద్దు. ఇది గ్రీన్ అయితే ఇది రెడ్ అని ఉండాలి, బ్లూ అని ఉండాలి, ఎల్లో అని ఉండాలి. ఇది ఒకవేళ ఎల్లో అవుతే ఇది బ్లూ అన్న, గ్రీన్ అన్న, రెడ్ అని ఉండాలి. లైక్ దట్ ఇట్లా చేసుకుంటూ వెళ్ళాలి. ఒకవేళ మనకి ఎక్కడైనా అటాక్ అవుతాయి, అటాక్ అంటే ఏంటంటే సేమ్ కలర్ వస్తే బ్యాక్ ట్రాక్ అవుతాం. బ్యాక్ ట్రాక్ అయ్యి దాన్ని మళ్ళీ సాల్వ్ చేసుకుంటూ వస్తాం. యూ get back like this. You get back like this, right? And you draw the colors. Fine. I'm reviewing this slide. So you just take down the question. There are 6 vertices and 4 colors. So this Hamiltonian cycle and all this is completed. Next, you are having a 0/1 knapsack problem. Okay, just here, state space is nothing but all paths from the root nodes to other nodes define the state space of the problem. ఇప్పటిదాకా మనం చేసింది దీన్ని స్టేట్ స్పేస్ ప్రాబ్లం అంటారు. ఒక రూట్ నుంచి, ఒక పాత్ నుంచి ఇంకొక పాత్ కి పోవడాన్ని స్టేట్ స్పేస్ అంటారు. సొల్యూషన్ అంటే ఆల్ పాత్స్ ఫ్రమ్ రూట్ టు సొల్యూషన్, స్టేట్ డిఫైన్స్ ద సొల్యూషన్ స్పేస్ ఆఫ్ ద ప్రాబ్లం. సో లైక్ దిస్, these are those problem states S for which the path from root to S define a tuple in the solution space. So these are the different tuples in any solution space. Clear? Next you have 0/1 knapsack problem. So in unit 3 you have knapsack problem. In that one you do not have 0/1. So ఒకవేళ మీరు 0/1 knapsack problem dynamic programming లో చేసి ఉంటే దీన్ని మనం ఏం చేస్తున్నాము, యూజింగ్ బ్యాక్ ట్రాకింగ్ వీఆర్ యూజింగ్ ద ప్రాబ్లం, రైట్? ఇన్ యూజింగ్ బ్యాక్ ట్రాకింగ్ యూఆర్ గోయింగ్ టు డూ ద ప్రాబ్లం. నెక్స్ట్ యూఆర్ హ్యావింగ్ knapsack problem, that is 0/1 knapsack problem, రైట్? చూద్దాం సార్ ఏమైనా నాకు ఇచ్చాడు ఆప్షన్. Fine. This search gives me access. Let us go to the next one. You're having branch and bound. Branch and bound. Then అర్థం ఏంటంటే B and B functions or B and B method. So in branch and bound, it is not used for optimization problems. Okay na? నెక్స్ట్ బ్యాక్ ట్రాకింగ్ వచ్చేసి సబ్సెట్స్. ఇప్పుడు మనం అన్ని స్మాల్ పీసెస్ చేసాము ఆర్ పర్మిటేషన్ ప్రాబ్లమ్స్ చేసాము, దాన్ని బ్యాక్ ట్రాకింగ్ యూజ్ చేస్తుంది. సో బ్యాక్ ట్రాకింగ్ యూజెస్ DFS, డెప్త్ ఫస్ట్ సెర్చ్. Okay, depth first search. It goes down till the leaf and then solves comes back, right? Next, backtracking is not good for optimization. And a simple single solution backtracking is not possible, because if you backtrack, it does not become an optimization problem. So this problem is rectified by using branch and bound techniques. So branch and bound is applicable only for optimization problem. So branch and bound ఏం చేస్తుందంటే bounding functions use చేస్తాము, right? Upper bound అనేది use చేస్తాము, right? So these are the different terminologies. Already we have done this one. So coming here. Now, nodes will be expanded in 3 ways. In branch and bound, you're going to do search the tree using breadth first search. I told you just now, breadth first search, that is called as FIFO. First in, first out. Ante first oka breadth ki ellin tarvata ikkada nenu chupisanu meeku diagram lo, right? So you're going to go in breadth first search. Next, search the trees as in BFS, but replace the FIFO queue with a stack. Queue కాకుండా stack తీసుకుంటున్నాము. Next, you are going to replace the FIFO queue with a priority queue. So maximum priority, right? So you don't have this concept in your this one. You don't have job sequencing also, right? Okay, backtracking వచ్చేసి మనకి డిఫరెంట్ అప్లికేషన్స్ ఉంటాయి. బ్యాక్ట్రాకింగ్ లో బ్రాంచ్ అండ్ బౌండ్ లో ఏం చేస్తారు? It is a process of generating sub problems. It's a process of generating sub problems. Yeah, it is a process of generating sub problems, and you will decide which sub problem to get maximum profit. State space 3. So you have 2 applications only in branch and bound. Only 2 applications are there in branch and bound, right? Yeah. So one is traveling salesperson problem. Do you all remember what do you mean by traveling salesperson problem? Traveling salesperson problem is nothing but a person starts from the source. Okay? He starts from the source, visits different cities. Okay, he visits different cities and again reaches back to the source with minimum cost. That is called as traveling salesperson problem. Okay, let us take one particular graph. Okay, let us take a graph and do it. Okay, all of us, let us take it down. Yeah. I'm traveling here. S is my source vertex. S is my source vertex. From here, I'm going to A. Its cost is 3. మీరు చేయాలమ్మా ఈ ప్రాబ్లం చేసి చెప్పాలి నాకు ఎలా చేస్తారు అనేది. S2 B. Its cost is 6. Next, from S2, you're having A to C. The cost of this problem is 7. Next, A to D. Please take down this problem. A to D, the cost is 2. Next, B to E, the cost is 6. Next, D to G, the cost is 4. సో అతను సోర్స్ నుంచి ఇక్కడికి వచ్చి మళ్ళీ సోర్స్కి వెళ్ళిపోవాలన్నమాట. సో మనం ఫైండ్ అవుట్ చేయాలి కాస్ట్. దిస్ ఇస్ దిస్ ఎండ్ నోడ్. సో హియర్ C to G, the cost is 5. Next, from D to E, the cost of traveling is 2. And from D to B, the cost of traveling is 3. This cost is 2. Okay. This is the traveling salesperson problem. You are going to start from S, come to G, visiting the nodes. How will you visit them? Just tell me. So how do you start is just see here. I will show you. Please take down this problem. Then we will start. So first what do? You start from the source, right? Next you visit the node. You visit the node with the shortest route. Ante S nunchi A ki ellachu, S nunchi B ki ellachu. If I go from S to A, so what is the possibility? Just here. If I go from S to A, the cost is 3. While if I go from S to B, the cost is 6. Clear? So the least cost here will be from S to A. Remember that. Here you're going from S to A, the least cost is 3. Clear? So here I am going to kill this particular route. Next, S to A kocham. Next, ఇప్పుడు A నుంచి ఎన్ని పాసిబిలిటీస్ ఉన్నాయి చూసుకోండి ఇక్కడ. రైట్? A నుంచి C కుంది, A నుంచి D కుంది, A నుంచి S కుంది. రైట్? నేను ఇప్పుడు ఏం చేస్తున్నాను ఇక్కడ? I am going from A to C. The cost of traveling is 7. If I am going from A to D, the cost is 2. ఇప్పుడు మనం ఇక్కడ ఏం చేయాలి? A to S కూడా పెట్టుకోవాలి. ఎందుకంటే you're going in a possible way. So right, A to S కూడా పెట్టుకుంటాం. కానీ మనం ఇది వెళ్ళాం. రైట్? నెక్స్ట్ A to S వచ్చేసి 6. అంటే ఇక్కడ చూడండి. A to S ఇక్కడ చూడండి. A to S ఎంత ఉంది? A to S వచ్చేసి 3. సారీ. So 3 plus 6 వస్తుంది. 3 plus 6. So it become 9. Again, if you're going back, you're starting from there and going back there. So you're going to get plus. So what is the shortest path here? You're going to go from A to D. Next, ఇప్పుడు D నుంచి ఎన్ని పాసిబిలిటీస్ ఉన్నాయి చూసుకోండి. D to G, D to E, D to B. Right? So what is the possibility? So from D to G, the possibility is 4. The cost of traveling from D to G is 4. Right? The cost of traveling from D to B is 3. D to B is 3. Next, the cost of traveling from D to E is 2. Right? While the cost of traveling, yeah. Now here, which is the shortest path? D to E is 2. కానీ E నుంచి ఎంత ఉంది చూడండి పాత్ ఇక్కడ. E నుంచి మళ్ళీ B కి వెళ్ళి, right? Again from B to D, D to G. So this is not possible. Right? Next, what do? You go for the next possibility solution. I am not going for E. Let us go for B. If I go from S to A, S to A to D, D to, what is the next one? S to A to D, and D to B. If I go to B, ఏమవుతుంది? మళ్ళీ ఈకి వచ్చి, మళ్ళీ డీకి వచ్చి, మళ్ళీ జీకి రావాలి. సో దిస్ బికమ్స్ అ డెడ్ లాక్. రైట్? సో దిస్ ఈస్ నాట్ ద పాసిబిలిటీ. సో అగైన్ యూఆర్ గోయింగ్ టు G. G is the end node. Right? G is the end node. So the cost to travel for the salesperson is 3 plus 2 plus 4. The cost to travel is 3 plus 2 plus 4. The total cost will be 9. ఇప్పుడు మీకు ఇంకేమైనా పాసిబిలిటీస్ ఉన్నాయో చూసుకోండి. సో దిస్ ఈస్ ద సొల్యూషన్ ఫర్ దిస్ పర్టికులర్ ట్రావెలింగ్ సేల్స్ పర్సన్ ప్రాబ్లం. సో వాట్ ఈస్ ద కండిషన్ ఆఫ్ ట్రావెలింగ్ సేల్స్ పర్సన్ ప్రాబ్లం? You need to go with minimum cost, and this is the optimal solution by using least cost branch and bound. B and B or LC B and B under the name. Right? Next. So let us just see what we have done till now. 1 minute. Let us just see. I'm sharing the screen. so that you will know what we have done. If you are not responding, you can just see here what all we have done till now, right? Okay, so we have done about backtracking. So it is nothing but space required is complexity. మీకు నాకు తెలిసి మీకు గుర్తుండాలి. Time complexity అంటే ఏంటి, సారీ big O అంటే ఏంటి, this is nothing but the notation, big O notation of tree height. So for this you are taking the backtracking. Wait, now you are going for backtracking. So in this, it searches the solution space tree in the depth first manner. It follows recursive procedure, or it uses a stack to retain the path from the root to the current node in the tree. In the tree, the solution tree exists only in your mind. అంటే మనం ఓన్ గా చేయాల్సిందే, కంప్యూటర్ లో ఎగ్జిస్ట్ అవ్వదు, రైట్? నెక్స్ట్, so in backtracking like this, you go for depth. You can just see here, this is the depth first search, right? Let me just check how many are there. Fine. You're using backtracking depth first search. Like this, you are going to find the solutions. చూడండి ఇక్కడ నేను ఎట్లా పెడుతున్నా చూడండి, different solutions, right? So you're getting the solutions like this. Okay, it keeps changing in this particular order. In this first one, we have done n queens problem. N queens problem అంటే ఏంటని చెప్పాను నేను. You are going for 4 queens. N queens or 8 queens is the same. So in this n queens problem, you are going to find the possibilities to place the queens in such a way that no two queens are in the same row or in the same column or in the same diagonal, right? That is called as n queens problem. So in n queens problem, there are 3 problems you will get: 4 by 4 queens problem, right? 8 by 8 queens problem, or 16 by 16 queens problem, or n queens problem, right? You get like this. These are the different possibilities you will get for in this particular in this particular question. Next, you have the next question, next possibility, next application. These are the different applications of backtracking. n queens అయిపోయింది. నెక్స్ట్ ఇస్ మనం సమ్ ఆఫ్ సబ్సెట్స్ ప్రాబ్లం చేసాం. సమ్ ఆఫ్ సబ్సెట్స్ అంటే ఏమని చెప్పాను నేను, ఒక ఆబ్జెక్ట్ 6 ఆబ్జెక్ట్స్ ఉంటాయి, రైట్? ఆ ఆబ్జెక్ట్స్ వచ్చేసి ఫిక్స్డ్ ఆర్ వేరియబుల్ సైజ్ టపుల్స్ ఉంటాయి. In sum of subsets problem, we use fixed size tuples, not variable size tuples. So here you are explained about fixed size tuples and variable size tuples, and you're going to put the objects in the bag such that the weight is not more than the size of the bag. Size istaru, objects istaru, then weights istaru. They should not be more than the size of the bag, and you should go in the following way, that you should decrease the weight of the bag. Clear? That is called as sum of subsets problem. You can just check here. This is sum of subsets problem. Okay. You can get it for variable size ante మనం size change చేసుకుంటూ వెళ్ళొచ్చు, or a fixed size tuple. You should always do for fixed size, not for variable size. Okay na? Variable size అంటే just ఇలా ఉంటుంది చూడండి. Variable size and ఇలా 1 2 3 4 5. So n is equal to 4. We're going to take from this one 2 3 4 5. ఓకేనా? దీని వేరియబుల్ సైజ్ అంటారు. సైజ్ మారుతూ పోతుంటాయి, నోట్స్ చేంజ్ అవుతాయి. ఫిక్స్డ్ సైజ్ అంటే ఇలా మనం చేసేది ఫిక్స్డ్ సైజ్, నాట్ వేరియబుల్ సైజ్. సో దిస్ ఇస్ ద algorithm for sum of subsets problem. So it uses fixed size tuple. Already I told you. Next, you're going to find the weights, and this is the formula for finding the weights. You need not require any formula. You can do it like the way I told you just now, right? So this bonding function strength further can be increased if you assume the weight WIS in increasing order. So what you're going to do, I'm going to put the weight inside it, increase the weight and decrease the size of the bag. Like that, you're going to increase and decrease. You can just see here, this is to increase the weight in the left hand side, and this is to decrease the weight to the right hand side. Total bag size తగ్గించుకుంటూ వెళ్తాము, మనం weights యాడ్ చేస్తున్నప్పుడు యాడ్ అవుకుంటూ వెళ్తాయి, right? Like this, you can take this particular question. I'll give you 1 minute, take down this question and solve it. నేను చెప్పినట్టు సాల్వ్ చేయండి. Please take it down. అయిపోయిందమ్మా మీరు ప్రాబ్లం తీసుకున్నారా? ప్లీజ్ చెక్ డౌన్ దిస్ ప్రాబ్లం. సో దిస్ ఇస్ ద జనరల్ మెథడ్ బ్యాక్ ట్రాకింగ్ లో ఏం చేస్తారంటే జస్ట్ ఇట్ ఈస్ అన్ ఆప్టిమల్ ఇట్ ఈస్ అ మ్యాక్సిమైజేషన్ ప్రాబ్లం. ఇట్ ఫాలోస్ రికర్సివ్ ప్రొసీజర్. మనకి ఆల్గోరిథం అవసరం లేదు. మనం ఎలా బ్యాక్ ట్రాక్ చేస్తున్నాం అనేది నేను మీకు ఒక ఎగ్జాంపుల్ ఇచ్చాను. దేర్ ఆర్ 2 boys and 1 girl and there are 3 chairs. How are we going to place them? 3 different combinations, you know, permutations and combinations, right? So you are going to place 2 boys side and girl to the right hand side. Next, girl to the first, then 2 boys to the right hand side, then again girl will come in between. So these are the 3 possibilities. If I say that girl should not come in between, what are the possibilities? Okay, question is done. The girl should not come in between. That will become one solution. If 2 boys should not sit together and a girl between those two. So like that, you're going to get different problems, right? Next, we have done graph coloring problem. Graph coloring problem ante entante you are going to assign the color to the vertices of a graph such that no 2 vertices share the same color, right? So vertices I and j are adjacent if there's an edge from vertex I to vertex j. So we have already done graphs. Hope you remember what are graphs. So this is one graph. You are going to color this graph with 2 given colors. So if question లోనే మీకు ఇస్తారు కలర్స్ ఎన్ని ఇస్తున్నారు అనేది వాళ్ళు మనకి ఇస్తారు, రైట్? 1 కలర్ ఇస్తే మనం గ్రాఫ్ కలరింగ్ చేయలేము కనుక యూ గివ్ 2 or 3. So if you give 3, you are going to put 3 here and one opposite color to this end. If you give 2, you are going to put it like this. Like that, you are going to put all the different possibilities. ఇక్కడ చూడండి, blue, red and gray. Again, the gray color is changed. So these are the possibilities. That's what I'm telling. Backtracking allows multiple possibilities, right? Like that, you will be given m colors and n vertices. So how will you do it? Right? Like this, you're going to find the solution. So where n is equal to 3 vertices and m is equal to 3 colors. So ఇది ఏంటి possibility. Next, 4 vertices, 3 colors. You can see it's a 4-node graph and all possible coloring. So ఈ గ్రాఫ్ నేనైతే ఏదైతే వేసానో దీన్ని స్టేట్ స్పేస్ ట్రీ అంటారు. స్టేట్ స్పేస్ ట్రీ ఏంటంటే ఒక వర్టెక్స్ ఉంటుంది, దాని సొల్యూషన్ ఉంటుంది. వర్టిసెస్ ఉన్న దాన్ని స్టేట్ అంటారు. స్పేస్ ట్రీ అంటే these proceedings, whatever you're putting these edges, those are called as edges, right? See here, finding all m colorings of a graph. Function m colorings begin by first assigning the graph to its adjacency matrix, setting the array x to 0, and then invoking the statement m coloring of 1. Ante first ikkada ఇది 0 అవుతుంది, right? This will become 0. Clear? This possibility, this question will become 0 here. Then you keep assigning to the next colors. So this is called as graph coloring problem. So I have shown you the possibilities. So you will get, these are the different answers you will get. Okay, these are the different answers that you will get. Next, what is that we have done? We have done about, what is that we have done? The last one, traveling salesperson problem. So what do you mean by traveling salesperson problem? Sorry, 0/1 knapsack problem. 0/1 knapsack ante 0 ante మనం weight ని బ్యాగ్ లో పెట్టాము, 1 ante weight completely బ్యాగ్ లో పెడతాము. That is called as 0/1 knapsack problem. Okay na? So 0/1 knapsack problem lo I have shown you. You can, I'll put it here. You just see. I'm going to add a new slide here. I'm giving 0/1 knapsack problem using backtracking. So it is 0/1 knapsack. This is the question. You have to solve it. Okay, here the size of the bag is 8. M is equal to 8. And the objects are 1, 2, 3, 4. So there are totally 4 objects. Right? You represent objects by n, small n. Okay na? Next వచ్చేసి దాని weights. The weights of the objects are like this. That is, you have 2, 3, 4, these are the weights. Right? Next, what are the profits of it? ఇప్పుడు నేను ఫస్ట్ వెయిట్ పెడితే ప్రాఫిట్ ఎంత వస్తుంది, సెకండ్ వెయిట్ పెడితే ప్రాఫిట్ ఎంత వస్తుంది. సో ఇక్కడ మనకి మాక్సిమం ప్రాఫిట్ రావాలి with minimum weight. I hope you remember I've told you about rice bags in a store. మనం రైస్ బ్యాగ్స్ తీసుకుంటామా లేకపోతే షుగర్ తీసుకుంటామా లేకపోతే ఆయిల్ తీసుకుంటామా? ఇఫ్ రైస్ ద కాస్ట్ ఆఫ్ రైస్ ఇస్ 1 kg is 50 rupees and 10 kg sugar is equal to 50 rupees, which one will you take? You're going to take 1 kg rice with 10 kg sugar with 50 rupees profit. Clear? 1 kg rice with 50 rupees profit. That will become the profit. So here, దీనికి మనకి solutions ఏమొస్తాయంటే చూడండి. You please try it. You're going to get the solutions like this. You're going to put, let me go to the next one. Here I'm putting the solutions. The solutions are, you should get these answers. The first object will be placed, second object will be placed, third will not be placed, fourth will not be placed. This is one possibility. First object will be placed, second will not be placed, third will be placed, fourth will not be placed. This is the second possibility. Again, third answer will get, first object will be placed, second will not be placed, third will not be placed, and fourth will be placed. Just ఏం చేస్తాము చూడండి. ఫస్ట్ పెడితే వెయిట్ వచ్చేసి 2, then profit వచ్చేసి 3. So 2 plus 3, here you will get 2 weight plus 3 weight. So third one is not placed, so 0 plus 0. So the weight of the bag will be how much? 5. This is the 5 weight and the profit will be 8. ఇక్కడ వచ్చేసి 8 profit. Clear? Next, in this case, you're going to put the first one's weight is 2. The second one's weight is 0. The third one's weight is how much? 4. And the fourth one weight is 0. I'm not putting it in the bag. So the total profit will be 2 plus, that is 3 plus 5 is not there. 6 is not there. 6 is there. So the cost will be, the profit will be 9. Next, in this case, what you're going to do? Let us go to this. Here, I'm going to put the first one's weight is 2, second one's weight is 0, third one's weight is 0, and fourth one's weight is how much? 5, right? So the total weight of this bag is 7. Okay, and the solution, the profit, what you're getting here will be, the profit is when you're inserting the first object 3 plus second object is not placed, so the answer is 0 here, and the third object you're not placing, the answer is 0 here, and 10. So here the answer is 13. So ఇది optimal solution అయితే ఇది ఆన్సర్ అవుతుండే, ఇది ఆప్టిమల్ సొల్యూషన్ కాదు కనుక డిఫరెంట్ పాసిబిలిటీస్ ఏంటి, దాని వెయిట్స్ పెడితే ఎలా ఉంటుంది. ఎందుకంటే మనం థర్డ్ యూనిట్ లో ఏంటి అది బ్రూట్ ఫోర్స్ మెథడ్ లో మనం నాప్సాక్ ప్రాబ్లం చేసాం. సో ఇఫ్ యు డు నాట్ పుట్ ద బ్యాగ్ కంప్లీట్లీ, యూ కెన్ అట్లీస్ట్ పుట్ ద పార్ట్ ఆఫ్ ద బ్యాగ్. అంటే ఇప్పుడు ఇక్కడ మనకి వెయిట్ 5 వచ్చింది, సో 3/8 ఆఫ్ ద బ్యాగ్ మనం పెట్టుకోవచ్చు అందులో. దట్ ఈస్ కాల్డ్ యాజ్ నాప్సాక్. And this is called as 0/1 knapsack, so that you can put the bag completely or you do not put the bag completely into the, the object completely into the bag. Next one, what we have done was branch and bound, right? In branch and bound, what did you do? Here, in branch and bound is nothing but backtracking is used for subset or permutation problems. It follows DFS method. While and backtracking is not good for optimization problems. So this optimization solution is whatever is error in backtracking is rectified in using branch and bound technique. So branch and bound is applicable only for optimization problems. It has bounding functions and it is similar to backtracking. దీనికి bounding functions ఉంటాయి, అంటే upper bound ఉంటుంది. That is called as branch and bound. Okay. So even in branching, it is the process of generating sub-problems, and in this you have to decide which sub-problem to get maximum profit, and you have a state space tree. This is called as state space, solution space. Just now I told you, all the paths from the root to other node define the state space. ఇంకొక path కి వెళ్ళడాన్ని దాన్ని state space అంటారు. సో ఇందులో ఇవన్నీ state space అవుతాయి, రైట్? సొల్యూషన్ స్పేస్ ఏంటి? ఒకటే పాత్ ఉంటుంది ఇన్ branch and bound. Right? That is called as state space, and this is called as solution space. Right? So you can just see here, problem state, this is the problem, this is the solution. Like this you do. So in branch and bound, the nodes, if మనం ఏదైతే state space tree draw చేసామో, they will be expanded in 3 different ways. That is you are using breadth first search, that is FIFO branch and bound. Next one, you are using Q. You are replacing this Q with stack, that is LIFO branch and bound. So FIFO అంటే ఏంటి, ఫస్ట్ ఇన్ ఫస్ట్ అవుట్. ఏదైతే ఫస్ట్ ఇన్సైడ్ అవుతుందో బ్యాగ్లోకి వెళ్తుందో అదే ఫస్ట్ బయటకు వస్తుంది. స్టాక్ అంటే ఏంటి, LIFO, విచ్ వన్ కమ్స్ ఇన్సైడ్ ఫస్ట్ will go outside first, right? Next, last inside first, then the first it will be outside first, right? Next, you are replacing this FIFO queue with priority queue. Priority queue is nothing but least cost or maximum priority branch and bound. Clear? So in this least cost, you are having different applications. One is knapsack problem and one is traveling salesperson problem. Just now I told you what is traveling salesperson problem. Let us just open that. Yeah, this is called as traveling salesperson problem. This person is going to travel different cities, right? This person is going to travel different cities and he has to get maximum profit. అంటే కాస్ట్ తక్కువ, ప్రాఫిట్ అంటే ఇక్కడ లీస్ట్ బౌండ్ బ్రాంచ్ అండ్ బౌండ్ లో కాస్ట్ కన్సిడర్ చేస్తున్నాం ఈ ప్రాబ్లంకి. సో తక్కువ కాస్ట్ లో నేను ఎక్కువ సిటీస్ కవర్ చేయాలి, రైట్? సో నేను ఏం చేస్తున్నాను, ఎస్ నుంచి ఏకి వెళ్తున్నాను, ఏ నుంచి డికి వెళ్తున్నాను, డి నుంచి జికి వెళ్తున్నాను. సో దిస్ ఈస్ ద పాసిబిలిటీ of branch and bound. Now coming to 0/1 knapsack problem. So you will get a question, knapsack problem using dynamic programming, knapsack problem using backtracking, knapsack problem using branch and bound method. Okay na? So ఇప్పుడు మనం ఏం చేస్తున్నామంటే 0/1 knapsack problem using branch and bound method you are going to take. Clear? Just a minute, let me just show you how are we going to take the branch and bound. So here you're going to get the 0/1 knapsack problem అనగానే మీకు గుర్తు రావాల్సింది ఏంటంటే there are profits and there are weights, right? So the profit, how many objects are there? In my problem I'm taking 4 objects. Rohit, please stop it. Right, there are 4 objects, Rohit. So the profit of the first object is 10, its weight is 2. The profit of the second object is 10, its weight is 4. The profit of the third object is 12, its weight is 6. The profit of the fourth object is 18 and its weight is 9. So how many objects are there? N is equal to 4. సో నాప్సాక్ అనేది గుర్తు రావాలి మీకు ఏంటిది, ఒక బ్యాగ్ అనేది ఎం లాగా రిప్రజెంట్ చేస్తాము. ఎం ఈజ్ ఈక్వల్ టు ద మాక్సిమం సైజ్ ఆఫ్ ద బ్యాగ్ ఈజ్ 15. అంటే మనం అన్ని వెయిట్స్ పెట్టలేము, ఓన్లీ మనం పెట్టేది ఏంటంటే టోటల్ వెయిట్ ఆఫ్ ద బ్యాగ్ షుడ్ బి 15 అండ్ ఇట్స్ ప్రాఫిట్ షుడ్ బి మోర్. సో ఇక్కడే మనం చూసుకోవచ్చు 2 + 4 is 6, 6 + 6 is 12. సో ద వెయిట్ ఆఫ్ ద బ్యాగ్ విల్ బికమ్ 12 అండ్ ఇట్స్ ప్రాఫిట్ is 20 + 12, that is 32. సో అదొక పాసిబిలిటీ. లేదు నేను 2 పెట్టాను, 4, 6, 9. So 10 + 6, 4 + 6 is 10, 10 + 9 is 19. So you cannot put 19 into the bag. You cannot put 19 into the bag. Next, what will I do? Other possibility. So ala possibilities చూసుకుంటూ వెళ్ళాలి, right? So here we need to put the using the objects. So how will you put the objects? Just see. So this is the objects. You please take down this question, right? So here we are going to use upper bound, branch and bound ante ikkada manaki upper bound untundi, right? You are going to get upper bound. I hope you remember what do you mean by that. In maths you will be having sigma I is equal to this is lower bound, the upper bound will be n. Okay, so here you have to calculate the profit. Upper bound is calculated like this, pi xi, where which is less than or equal to the total size of the bag. అప్పర్ బౌండ్ వచ్చేసి బ్యాగ్ సైజ్ కన్నా ఎక్కువ ఉండద్దు. ఇప్పుడు మనం కాస్ట్ ఎలా క్యాలిక్యులేట్ చేస్తాం, ఈ బ్యాగ్ ని పెట్టడానికి, బ్యాగ్ లో వెయిట్స్ పెట్టడానికి ఎలా క్యాలిక్యులేట్ చేస్తాం అంటే సి ఈజ్ ఈక్వల్ టు sigma I is equal to 1 to n, the profit pi xi, right? This is pi xi with fractions. Here you are going to use the cost with fractions. Remember that. Okay, here you are using fractions, whereas in upper bound you are not using any fractions. Just remember that, right? Let us go to the question. So you are going to generate the space tree. For that you require some solutions, right? First లో మనకు అప్పర్ బౌండ్ వచ్చేసి ఇన్ఫినిటీ. మనకు ఎందుకంటే మనకు తెలియదు అప్పర్ బౌండ్ ఎంతనో తెలియదు. మనం అప్పర్ బౌండ్ ఐడెంటిఫై చేయాలి, రైట్? అప్పర్ బౌండ్ విల్ బి ఇన్ఫినిటీ, రైట్? So what you are going to do? First I am going to take the first object, right? When I take the first object, when I take this first object, what will happen? The cost I'm going to calculate is C is equal to, right? Profit and weight I have to take, right? So the weight of the bag will be, so I'm taking 10. So here the profit is 2 plus 4. Second object weight is 4. The third object weight, what is the third object weight? Tell me. Student, I have to go back again. The third object weight is 66. So when I put this 3, it will become 14. I cannot put fourth object. So cost calculate చేసేటప్పుడు ఏం చెప్పాను? Fractions వస్తాయి, right? So the profit, its weight is 9. How much place is left here? How much space is left here? You can put 3 into the bag. Okay. So what is the weight here? 18 divided by 9, it is 2. So how much will you get here? How much will you get here? You are going to get 2 plus 4 plus 6 is the weight of the bag. 2 plus 4 plus 6 వచ్చేసి, you are going to get 12. ఇక్కడ 2 plus 4 plus 6, the weight of the bag, right? I am calculating this one. So the upper bound will be totally, the upper bound will be C is equal to, this is minimization problem. Minimization problem ante negative values వస్తాయి, right? So the cost will be minus 38. You can see the cost. It is totally, it is minus 38. And upper bound is equal to 10 plus 12. So as it is minimization problem, you're going to take minus 32. Clear? In the first step, this is the solution, right? Next, what will I do here? I'm going to take the root node, right? In this, when I put the first object in the bag, x1 is equal to 1. ఈ ఆబ్జెక్ట్ పెట్టినప్పుడు అప్పర్ బౌండ్ ఎంత ఉంటుంది? అప్పర్ బౌండ్ is equal to minus 32. And the cost, what I have got here? Cost is equal to minus 38. The cost of the putting that, this one. If I put, ఇప్పుడు ఇక్కడ లీస్ట్ కాస్ట్ ఎంత అవుతుంది? నేను ఫస్ట్ వెయిట్ పెట్టినప్పుడు పెడితే ఎంత అవుతుంది? అప్పర్ బౌండ్ విల్ రిమైన్ ద సేమ్, ఎందుకంటే మనం ఫస్ట్ ఆబ్జెక్ట్ పెడుతున్నాం గనక. minus 32. And the cost here will be minus 38. So ఇది breadth first search కనుక ఇప్పుడు x1 is equal to 1 పెట్టాను. x1 is equal to 0. ఇప్పుడు నేను ఫస్ట్ వెయిట్ పెట్టట్లేదు బ్యాగ్ లో. పెట్టినప్పుడు ఎంత అవుతుంది? ఇక్కడ అప్పర్ బౌండ్ ఎంత అవుతుంది? దాని ప్రాఫిట్ తీసేయండి. ప్రాఫిట్ వచ్చేసి 10. సో 32 minus 10. So it become minus 22. దాని ప్రాఫిట్ తీసేయాలి మనం, రైట్? And the cost here will be 38 minus 6. So it will become 32. You can just see here. How did you find the cost? అంటే చూడండి ఇక్కడ ఈ కాస్ట్ ఎలా ఫైండ్ అవుట్ చేస్తాము? The first bag profit వచ్చేసి 10. Second bag profit వచ్చేసి 10. Third bag profit వచ్చేసి 12. Right? Fourth bag profit was how much? 18 by 9 into 5. So here the cost will become 32. ఈ కేసులో 32 అవుతుంది. When I do not put the first weight of the bag. Clear? You have to do like this. So the cost incurred here will become minus 32. Next నేను ఏం చేస్తున్నాను, బ్రెడ్త్ ఫస్ట్ సర్చ్ అయిపోయింది. నెక్స్ట్ లెవెల్కి వెళ్ళాలి, డెప్త్కి. దీన్ని x2 is equal to 1. ఇప్పుడు 1 అన్నప్పుడు ఏం చేస్తాము, దీని వెయిట్ని మనం ఇన్కర్ చేస్తున్నాం. ఇన్కర్ చేసినప్పుడు ఏమవుతుంది, u is equal to అప్పర్ బౌండ్ will still remain minus 32. The cost will still remain, ఎందుకంటే మనం అన్ని పెడుతున్నాం కనుక cost will be minus 38, right? So when I put this, it will become like this. Then if I do not put x2 ని పెట్టకపోతే, so ఇలా మనం బ్రెడ్త్ ఫస్ట్ చేసుకుంటూ వెళ్ళాలి. If I do not put x2, what will happen here? You will get cost upper bound will be, దీని ప్రాఫిట్ కూడా 22. సో ఇక్కడ మనం ఫస్ట్ బ్యాగ్ పెట్టి ఫస్ట్ ఆబ్జెక్ట్ పెట్టిన తర్వాత సెకండ్ ఆబ్జెక్ట్ పెట్టట్లేదు. సో దిస్ విల్ బికమ్ minus 22, right? And the cost will become, right, it will become minus 36. ఎందుకంటే మనం ఆబ్జెక్ట్ పెట్టకుండా వెయిట్ ని పెడుతున్నాం, రైట్? ఆబ్జెక్ట్ తీసేస్తే ఎంత ఉంటుంది మనకు వెయిట్, రైట్? అది చూసుకోండి ఇక్కడ. ఇట్ విల్ బికమ్ minus 36, not 38, minus 36. In 36, I'll show you this example here. So what is happening here? The cost, the profit here is 10. Okay na? 10 plus 10 plus 12. So ఇక్కడ ఎంత అవుతుంది ఇక్కడ? I am not putting 10. So what will happen here? 10 plus 12 plus 18. 18 by 9. అంటే ఇప్పుడు ఇక్కడ ఎంత మిగిలింది మనకు వెయిట్ చూసుకోండి. ఇక్కడ ఫస్ట్ ఆబ్జెక్ట్ పెట్టినప్పుడు మనకు ఆబ్జెక్ట్ వెయిట్ వచ్చేసి 2. సెకండ్ ఆబ్జెక్ట్ పెట్టట్లేదు కనుక 0. థర్డ్ ఆబ్జెక్ట్ పెడుతున్నాను కనుక 6. If I put 8, if I put the fourth object, the object 8 is 9. So ఎంత అవుతుంది? 9 plus 6, 15 plus 2, 17. What is the size of my bag? What is the size of my bag? The size of the bag is 15 only. Remember that. The size of the bag is 15. So ఏమవుతుంది ఇక్కడ మనం ఏం చేయాలి? ఇక్కడ మనం ఎంత చేస్తున్నాము? 2 plus 6 is 8. 7 weight ఉంది దానికి, ఇంకా మనం 7 పెట్టచ్చు. So 9, 18 divided by 9, 2. So here the total profit will be 10 plus 12 plus 14. So here you are going to get 36 here in this case. In this case you are getting minus 36. Clear? Hope this is clear, right? Next, when I am putting this, I am getting this is the answer. ఇలా మనం step by step చేసుకుంటూ వెళ్ళాలి, right? I'll give you this question again. You can do it later. Then I have come to x2 అయిపోయింది. x2 అయిపోయిన తర్వాత ఇప్పుడు ఏం చేస్తాం మనము? దీని అప్పర్ బౌండ్ వచ్చేసి minus 36 ఉంది, కానీ ఇక్కడ మనకు హైయెస్ట్ అప్పర్ బౌండ్ ఎంత ఉంది? ఇక్కడ minus 38. సో దానికన్నా ఎక్కువ వస్తేనే దాన్ని మనం కంటిన్యూ చేస్తాం, అదర్వైజ్ వీఆర్ గోయింగ్ టు కిల్ ఇట్, right? Next I'm going to x3. x3 is equal to 1. x3 is equal to 0. If I go for x3 is equal to 1, the upper bound will be 32, right? Upper bound is minus 32 and the cost will be minus 38. You can just calculate it. Coming here, the cost will be minus 38 when I'm not putting x3 into the bag. I told you just now how to put and how, when you do not put, how to calculate the weight. Okay, when you are putting, the weight will remain the same. When you are not putting, you have to remove that object profit as well as the weight. So here it will become minus 38 will be the cost. And upper bound also will become minus 38. మీరు calculate చేసుకొని చూడండి, you will get the same answer, right? So this is the smallest upper bound. Upper bound was minus 38. Again, with the cost, this is the smallest upper bound. So I'm going to update this one. Answer వచ్చేసి minus 38 రావాలి, right? Next ఏం చేస్తున్నాను నేను ఇక్కడ? I am going to take the fourth possibility. ఇప్పుడు ఇక్కడ ఎందుకు తీసుకోవట్లేదు? Because it has already reached the bound. That's why I'm not taking here. When I'm taking x4 is equal to 1. I said you are going to update the possibility. So when I'm updating it, this will become the answer. So when this is 1, the upper bound here it will become u is equal to ఎంత అవుతుంది ఇక్కడ 32 ఉండే సో ఇక్కడ 38 వచ్చింది సో దిస్ విల్ అప్డేట్ హియర్ సో u will become minus 38 and the cost also will become minus 38. Clear? When x4 equal to 0, what is the cost you will get? You're going to get u is equal to, the cost will be lesser, that is you may get around 20, and the upper bound will become 20. Sorry, it will become minus 30, 32. So this is less than minus 38. So you are going to kill it. So what is the solution here? It is an optimization problem. So the solution is you are putting the first weight, the second weight, you are not putting the third weight, you are putting the fourth profit into the bag. So this is the profit you are going to get. I'm going to get the 38 as the profit. Okay, at this point of time, 38 is the profit and the weights will be 2, 4, 9. You can just check here. 2 plus 4 is 6. 6 plus 9 is 15. So the total weight of the bag, this is the traveling salesperson problem. Okay, na? You just complete this problem. You will be having another, ఏముంది ఇంకా ఇప్పుడు మనం కంప్లీట్ చేసింది ట్రావెలింగ్ సేల్స్ పర్సన్ ప్రాబ్లం 0/1 knapsack ప్రాబ్లం ఇవి రెండు కంప్లీట్ అయిపోయాయి రైట్ in branch and bond. You only have 2 things in branch and bond that we have completed, right? Tomorrow we will go for 5th unit, that is NP hard and NP complete problems, right? Here I'm giving the question. You can do it later and check. Okay. This is the profit. This is the weight, right? The profit is 10. The weight is 2. The profit is 10. The weight is 4. The profit is 12. The weight is 6. The profit is 18. The weight is 9. So the total weight of the bag, N is 4. The bag size is 15. You can just check directly. ఇక్కడ చూస్తే మనకు ఆన్సర్ వచ్చేస్తుంది చూడండి. You can put x1 is equal to 0, x2 is equal to 0, x3 and x4 బ్యాగ్ లో పెట్టుకోవచ్చు. లేదు అంటే 2 plus 4 plus 9, or you can go with 4 plus 6 వచ్చేసి 10, 6 plus 10 plus 9, 19. So this is not a possibility. You can either put x3 and x4, or you can put x1, x2 and x4, right? Or you can put 1, 2 and 4. Clear? So this is about unit 4. Fine. Tomorrow we will do unit 5, right? Thank you. Sir? Someshwar, sir. Yes. Are you all there? ఎంతమంది ఉన్నారు ఇక్కడ? Okay, fine. You can leave the class. You can leave the class. You can leave the class. The 4th unit is completed. You can go for the 5th unit tomorrow. I am leaving. Please leave the class. I am leaving the class. You can leave the class. The 4th unit is completed. Fine.